Okay, there seemed to be some confusion on that valve that I posted, the overflow valve. So on here, I'm going to try to make it easier to understand. So just if I can, right here. So if you see, the corn comes in the top here where the yellow is and comes down through. With the valve over this way, it all goes to the wet bin. With the valve like this, it all goes to the grain dryer. Pink is the dryer, blue is the wet bin. With it like this, everything goes to the wet bin. I think everybody understands that. With it like this, the corn all goes to the dryer. I think everybody understood that. The place where people didn't understand or seemed to have some confusion was in this right here. When this paddle is straight up, how the overflow is. Now this is drawn to scale, unlike the hand sketch in my last video. This is drawn to scale. So if we go at and we make, this is a 10-inch valve, and I'm not gonna share every detail of it, but if you look at this line is a 10-inch long line. There is 10 inches from the top of that to the other edge over here, even though it's at an angle. There are more than 10 inches on the other side. See that line on there? There's more than 10 inches on that side. There's 10 inches on this side. There's a couple inches more over here, actually. There's more than 10 inches from the top of this to any part here. The closest that the top edge is to any metal is to this side of the valve. So this 10 inches is the smallest. Up here, we have like 14 inches, something like that. Over across here, there's way more than enough room so that if the grain in here is piled up here, boiling in here, it comes across. The other thing is the width of the valve. The thickness of that valve, if it's a 10-inch valve, it's going to be a minimum of 12 inches this way. So if we do a little bit of simple math, we have a 10-inch by 12-inch opening at the smallest in that valve. A 10-inch circle, which would be the size spout going to it, would be 78 square inches of opening in a 10-inch circle. 78, remember that number. If we have 10 inches by 12 inches at our smallest point, that's 120 inches. So if you would take 78 inches of the round pipe times 1.5, that is still not as much as the room we have at our smallest location in this valve. We're going to look at the installation and operation of a K-flow valve. So a standard overflow valve, the grain would come in the top of it, flow down through, flood fill the dryer. On all of these drawings that we're going to be looking at, the pink is the grain dryer, the light blue is the wet bin. Grain dryer, wet bin. So normal overflow valve, however it falls, it goes in here, it fills up your dryer pipe, it goes in the wet bin. Now, if you look at the design of this here, we have our distributor here, and then we have our elevator discharge, and then our distributor. With this installation of the overflow valve, the grain is going to be coming in at this angle. So at this angle, I'm going to say, guessing, you're going to have half your grain getting on the other side of this plate and going directly into the wet bin. So only half of your grain is going to go into filling the dryer with this installation configuration, because this grain is coming in at this angle and it's angled towards the wet bin. So a bunch of the grain is going to go to the other side. When you're unloading a truck, if half of that truck dumps into the dryer, it is enough to overflow this and flood in, so all of it's going to the wet bin. So half of that grain going to the wet bin while unloading a truck is not a problem. If we look, this is not the ideal way to install, but we're going to look at how this is not actually as bad as it appears at face value. We move over here to this install where we have it installed like at this angle. So now you see that you have your elevator, your distributor, and your overflow valve. Now here, your grain is headed to the back of the overflow valve. 90% of your grain is going to go down into the dryer on this setup. This is the best install. Now, not 100% of the grain is going to go down to the dryer. You're going to have a little scattering over here, hitting here, bouncing back, scattering over here. This top of this valve is a couple inches closer to this side than this side. So the majority of the grain, this is the only overflow that has this short of a distance and this offset by this many inches from the inlet here to down here, because that plate is not straight. That plate is on an angle when it's in the what we call sender position. So this way of installing, 90% of the corn is going to the dryer. Now, when the installers are installing, it is not always possible to install it this way. It does not have to be installed this way, and I'm going to explain why. So let's say that that it is installed like this on your facility, or the facility you're building, it needs to be installed like this. While you're unloading trucks, you let it in the center position. When you're done unloading trucks, the benefit of this K-flow valve is when you're done unloading trucks, flip your valve so that when you're pulling out of the wet bin, it is 100% going into the dryer. This is one of the big benefits to this valve. If you see, when that plate's over there, now we have 100% of the corn going into the dryer. So overnight, you switch that over, 100% of the corn goes into the dryer. The morning when you start unloading trucks, you switch your valve back to the center position and you start unloading trucks. At this point, there isn't a electronic controller on that valve, but I really think that needs to be one of the options, is to have electronic controls on that valve. So that way, when the dryer calls for grain, it would actually move it over like this. And when the dryer's not calling for grain, it would bring it back to the center point. That's something that I really think we ought to have, and I'll discuss with engineering on how to make that happen. So now we're going to look at the way the controls are installed, the manual controls that we have at this time. So these controls here are the controls for controlling that valve. There's this handle here. This needs to be up. That handle needs to be up on the right-hand side. This needs to be up. This here is the bottom. This handle here, right here you can see the holes. That is where your cable should be fastened. And over here, this is where your cable should be fastened. So you pull down on this handle to release the valve, and you use your other hand to turn this right here to switch the valve from one position to another. So whenever installing, make sure this handle is up on the right hand side. This is up. This is down. These holes are up. So that way the cable can go through them holes and be on the top of the handle.